I do want to do one little side note about this. So the big part of this error right here is coming from the fact that I'm getting a stagnation pressure that comes after a shock wave. However, I can, if I want to, using the tables and my knowledge of the Mach number, figure out what the stagnation pressure would have been before the shock wave. Like I have P1 right here, which is measured as, let's see here, what is it? I think it's 2,116. And I have P02 over here, which is 7,712.8. Yes. I can look up from the tables what P02 or P01 is. I can go to the appendices for that. So let's go ahead and do that. Our Mach number, zooming in, forgot about that. Our Mach number was 1.56. So let's go down there and find out what P02 or P01 was. Because this can actually give us a correction here. Now, you're wondering, like, why don't they do that normally? You can, but if it's going supersonic, this is probably not the best way to be measuring the, velocity. Okay, so right here is 1.56. And I find that P02 or P01 is 0.90970. See that right there? That is my P02 or P01. So I'm going to go ahead and write that down. So I'm going to say, okay, well, P02 over P01 is equal to 0.9197. Okay, so with that, we can begin to correct things. So I want to know what P01 is. That's going to be equal to P01 over P02 times P02. That's going to be the answer. And so I have all those values. Notice this is P02 over P01. I'll have to invert it. So it's going to be equal to 1 over 0.9197 times my pressure, P02, which is 7,712.8. Okay, and that gives us P01. So let me plug that in my calculator. I don't actually have this one written down. This is just a fun little side problem here for us. So let's do this thing. You can see that it's going to be higher. 7712.8 divided by 0.9197. So I get a stagnation pressure before the shock wave of 8,386. 8,386, which makes sense because our stagnation pressure is supposed to drop after a shock wave because of the entropy. Okay, and that's pound force per foot squared. So let's go back to our equation for velocity and calculate it. Once again, this is Bernoulli's, but now with a corrected stagnation pressure. So I'll have 2 times 8,386 minus 2,116. That was the static pressure right there. That's the stagnation pressure I corrected. All over the density, which is, let's see, 0.00238 slugs per foot cubed. Okay. So let's plug that in my calculator and see what I get. So give me 1 second. And I get a velocity. Did I do this one right? I believe I did. A velocity that is equal to 2,295.4. Okay. So that becomes my velocity after the shock wave. Let's see. Whoop. Zooming in again. Keep on doing that. And what this shows us is it got even worse. It actually was even worse now. My percent error actually has increased. So measuring the velocity after the shock wave actually helped it be slightly more accurate for being compressible. Because last time, this is more than my 2,000, let's see here, 172. And so my percent error is going to be even higher. Be higher than 24.71%. So we were actually closer to the correct answer. So even correcting my stagnation pressure to the correct value does not fix our calculations when it comes to compressibility. Like compressibility is still completely throwing this off. So, fun little detail. Wanted to give you that little extra tidbit there.